Have you ever wondered why the Dead Sea is so unique? Let's dive into the science behind its wonders. The Dead Sea, nestled between Jordan and Israel, holds secrets that physicists find fascinating. Join us on this exploration of the surprising physics that make the Dead Sea an extraordinary place. Have you ever experienced the sensation of effortlessly floating on the surface of the Dead Sea? But let's break it down further. Imagine you have a pool with regular water and another with Dead Sea water. If you try to float in the regular pool, you might sink a bit, right? But in the Dead Sea pool, the high salt content changes everything. The water becomes denser, creating a stronger upward force called buoyancy. This buoyant force is what makes you feel lighter, almost weightless, and lets you effortlessly float on the surface. So, the next time you find yourself floating in the Dead Sea, remember, it's not just magic, it's physics in action. Now that we've explored the buoyancy of the Dead Sea, let's dive into another intriguing aspect, the optical illusions at play beneath its surface. The Dead Sea is not just about floating, it's also a place of optical illusions. Dive in, and you'll notice things underwater appearing all distorted. This isn't a magic trick but a physics phenomenon. The high salt concentration messes with how light moves through the water, creating illusions that play with our eyes. Let's get a bit technical. When light passes from one medium, like air, into another, like water, it changes speed and direction. This change is called refraction, and in the case of the Dead Sea, the high salt concentration alters the water's refractive index. This change in index causes light to bend differently, creating the distorted images we see underwater. So, the next time you're snorkeling in the Dead Sea and things look a bit surreal, remember, it's not a dream, it's the physics of refraction in action. Why is the Dead Sea always warm? Having explored the wonders of refraction, let's turn our attention to another phenomenon, the Dead Sea's ability to remain warm, even during chilly months. Even in chilly months, the Dead Sea remains warm. How? Well, physics has an answer. The high salt concentration helps the lake hold on to heat. Think of it like a cozy blanket for the water. This thermal stability, influenced by dissolved salt, keeps the Dead Sea toasty, no matter what the weather is like outside. Let's simplify it. Imagine the sun shining down on two lakes, one regular and one like the Dead Sea. The regular lake might lose heat quickly as the sun sets, but the Dead Sea holds on to it. Why? Because the dissolved salt in the water affects its specific heat capacity, making it better at retaining heat. So, even when the air gets a bit chilly, the Dead Sea's warm embrace remains, creating a comfortable environment year-round. From the warmth of the Dead Sea, let's dive into the magical properties of the mud found along its shores, talking about the mud along the Dead Sea shores. People love it for its supposed healing properties, but what's the science behind it? Physics comes into play with something called rheology, the study of how things flow. The mud is like a special kind of goo that flows like a liquid but stays in shape like a solid. Physics helps us understand why the Dead Sea mud feels so magical. Picture this, you scoop up some mud from the Dead Sea and let it flow through your fingers. It's smooth and gooey, right? But as soon as you stop, it holds its shape, like a mini mud sculpture. This is because the mud's rheological properties are influenced by the interactions between its particles. The finely dispersed solid particles in the mud create a structure that allows it to flow when you want it to and hold its shape when you're done. So, when people talk about the wonders of Dead Sea mud, they're not just talking about folklore, they're talking about the physics of flow and structure. Let's now understand the challenge it faces, its shrinking dimensions. The Dead Sea is facing a bit of a challenge, it's getting smaller. Physics can explain this too. The sun is super strong here, causing a lot of water to evaporate. With the high salt content, the water evaporates even faster, leaving behind concentrated minerals. This process involves fluid dynamics, thermodynamics, and environmental physics. Let's break it down. The sun's heat makes the water molecules in the Dead Sea gain energy, turning them from a liquid into a gas. As they rise into the air, they leave behind the minerals, making the remaining water more concentrated and salty. This increased salinity then enhances the evaporation rate. The interaction between these two fields is complex, and researchers are working hard to understand it better. And that's a wrap, physics enthusiasts. If you enjoyed unraveling the mysteries of the Dead Sea with us, don't forget to hit that like button and subscribe to Physics Daily for more mind-bending journeys through the fascinating world of physics. What's next on our scientific plan? Well, you'll have to stay tuned to find out. Until then, keep your curiosity alive. See you in the next episode on Physics Daily, where science meets curiosity.